Okay, so in this section we're going to talk about radicals, and some of this we've already talked about, but you probably know this. The square root of 25 is 5 because 5 squared is 25. Now when you find the square root of a fraction, if the numerator and denominator is perfect squares, then you can just take the square root of the numerator over the square root of the denominator. But you could also figure this out, that if you took 3/4 times 3/4, you got 9/16. So that's another way to get the square root. So the square root of 9/16 is actually the fraction 3/4. Now, as I said earlier, the square root of a negative number is not real. So the square root of negative 64 would be not real. And then this one actually is minus the square root of 64. Now that's different than this one. This one, you take the square root of 64, then you multiply it by -1. And since the square root of 64 is 8, then -1 times 8 is -8. So that would be -8. And as I said earlier, the cube root of 125 is just 5 because 5 cubed is 125. The cube root of -125 is -5 because the cube root of -125 is -5. Well, let me say that again. If you cube -5, you get -125. The fifth root of 343 is 3, and you can do this on scratch paper if you like, but if you multiply 3 out 5 times, 3 times 3 times 3 times 3 times 3, you'll actually get 243. And then the fourth root of 256 is 4, because if you multiply 4 times 4 times 4 times 4, you'll get 256. In other words, 4 to the fourth is 256. And then let's practice writing some expressions in radical form. I showed you earlier that x to the 1/2 is just means the square root. So 1/2 is just square root. So x to the 1/2 would be square root of x. And of course, if you raise something to the 1/3 power, you're taking the cube root. So this would be cube root of the expression 5a plus 1. And then here we have 4 times y to the 2/3. Now be careful here. The 4 is not raised to the 2/3, only the y. So we leave the 4 out here, and then y to the 2/3 would be the cube root of y squared. And then here you have the square root of xy. We're supposed to write this in exponential form. Well, since both of these are under the square root, then we could say this is the quantity xy raised to the 1/2 power. Now here you've got 5 times this fourth root, but the 5's not in the radical, so we would only take the 3x plus 2 and say that's raised to the 1/4 power, and we keep the 5 out here by itself. And then here we have the cube root of x minus 5 to the 5th. Well, that would be equivalent to x minus 5 to the 5/3 power, because remember 5 is the power, and the numerator here is the power and the denominator is the root. A couple of radical properties that come in handy, and this only works if the radicals are real numbers. So we'll deal with that later if it comes up. Okay, so the nth root of xy is actually equal to the nth root of x times the nth root of y. So where that's helpful is if I have the square root of 32 and I want to simplify that. Well, 32 is not a perfect square, but 32 has a factor that's a perfect square, 16. So I could write 32 as 16 times 2. So the square root of 32 is equal to the square root of 16 times 2. And then I could use this property to break that up into the square root of 16 times the square root of 2. And then I know the square root of 16 is 4. So I have 4 times the square root of 2. And let me show you this other property here. If you have the nth root of a quotient, x over y, you can write that as the nth root of x divided by the nth root of y. Let me drop down here to the last one to show you that. So if I have the square root of 9x squared over 25y to the 4th, I could actually write that as the square root of the numerator, 9x squared, over the square root of the denominator, 25y to the 4th. There was a typo there, but that should be 25y to the 4th. So now I can take the square root of 9 and get 3, and the square root of x squared is x. And then the square root of 25 is 5, and the square root of y to the fourth is just y squared. And so those properties can help me simplify radicals. Now we don't have to do them just on square roots. You can do them on cube roots to help me simplify radicals. Let's say I wanted to simplify the cube root of 108. Well, 108 is not a perfect cube, but 27 is, and 27 is a factor of 108, so I can write 108 as 27 times 4. And then I can break this up into the cube root of 27 times the cube root of 4. And we know the cube root of 27 is 3, so then this could be written as 3 times the cube root of 4. Alright, here's another one. This is a square root again. So we have the square root of x to the fifth times y to the fourth. Now, I can't take the square root of x to the fifth, but I can take the square root of x to the fourth. So what I'm going to do is I'm going to write x to the fifth as x to the fourth times x. And see, I can take the square root of x to the fourth, and I can take the square root of y to the fourth. So I'm going to keep those together in their own little radical, and then I'm going to separate it from the x. So I'm going to write this as the square root of x to the fourth, y to the fourth, times the square root of x. And of course, the square root of x to the fourth is x squared. The square root of y to the fourth is y squared. So I can write this as x squared, y squared, times the square root of x. Okay, here's another one. 45 is not a perfect square, but if I write 45 as 9 times 5, then I know I can take the square root of 9. Now x to the ninth is not a perfect square, but I can write x to the ninth as x to the 8th times x. And then y to the 7th, not a perfect square, but I can write y to the 7th as y to the 6th times y. So in other words, I'm breaking this up into a factor here where I can take the square root of all of these factors, and then I have another factor here where I can't take the square root of it, so I have to leave that in the radical. So go ahead and take the square root of 9, and I get 3. The square root of x to the 8th is x to the 4th. The square root of y to the 6th is y cubed. And then this, the 5xy, has to stay in the square root. And so that's how you would simplify that one. Now, this is a cube root. Now, I can't take the cube root of 81. 81 is not a perfect square, perfect cube, I mean. So I can't easily take the cube root of 81, but I can take the cube root of 27. So I'm going to write 81 as 27 times 3. Now, I can take the cube root of x to the 12th and y to the 9th. See, because I know if I multiply x to the 4th times x to the 4th times x to the 4th, I get x to the 12th. So in other words, if I cube x to the 4th, I get x to the 12th. So the cube root of x to the 12th would be x to the 4th. And then if I cube y to the 3rd, I get y to the 9th. So the cube root of y to the 9th would be y to the 3rd. And we know the cube root of 27 is 3. So I can take the cube root of 27 and get 3, the cube root of x to the 12th to get x to the 4th, and the cube root of y to the 9th to get y cubed. Oop, pizza's here. And then I can, alright, so yeah, the pizza's here. So, but we're going to continue working here. Okay, so 3x to the 4th, y cubed. And remember, I couldn't take the cube root of 3, so I had to leave it in the radical. Okay? Now this one, I can take the fifth root of negative 32, as we saw earlier, and that's going to be negative 2. And then if you take the fifth root of a to the 10th, that's actually going to be a squared. And then if you take the fifth root of b to the 15th, that's going to be b cubed. Now I'll show you a kind of a way you can figure these out, how I'm getting this a squared and this b cubed here. If you'll just let me show you, let me set it up for you. Okay, so what you can do here, if you want to find the fifth root of a to the 10th, you can think of this, it's a to the 10th raised to the 1/5 power. And then remember, you multiply the exponents. So if you multiply 10 times a fifth, that would be 10 over 5. And so that's going to give me a to the 10/5, which is a squared. And then if you want to raise b to the 15th, you want to take the fifth root of that, then raise b to the 15th to the 1/5 power, and then multiply exponents, and you get b to the 15 over 5, which is b cubed. So basically all you're doing is dividing the 5 into the 15 to get b cubed, and the 5 into the 10 to get a squared. Okay, so that's a little shortcut you can use there. Now on this one, I'm going to go the opposite direction that I did here. So here I'm actually going to take the square root of the numerator over the square root of the denominator. I'm going to write this as a single square root. And so I get square root of 32 over 2, which is square root of 16, which is 4. And so I've already done this last one, so that should be all of those. So I think I'll shut this video off here, even though I've got a few more minutes I could use. But I want to do, on the next videos, I'm going to start doing operations on radicals, like where you're adding radicals or multiplying radicals. But we'll do that in the next video.